Present, good afternoon to everyone present over here. Today, myself, Dr. J. Abdul Bari, Department of Civil Engineering, I am going to take the topic on engineering mechanics, fundamental concepts of mechanics. First of all, we have to look after about the mechanics. What is mechanics? Mechanics is nothing but a branch of science which deals with study of body, which are all at rest and with motions. We can be able to see that mechanics is the oldest of the form of the physical science, and it has been brought up from the achievements by the year of 287 to 212 BCs. Mechanics is a branch of physical science that is concerned with the state of rest or motion of the bodies subject to the action of the force. Basically, the applications of mechanics are the motions of vehicles such as trains, buses, etc., and the design of buildings and forces on the columns as well as the walls. So we will record to the branch of the mechanics. So branch of mechanics consists of one, that is statics as well as the dynamics. The statics is nothing but the study of the body which are all at rest, whereas the dynamics is nothing but the study of the body which are all under motion. We can clearly look into this. The branch of applied mechanics which deals with the forces and the effects of it while acting upon the bodies which are all at rest is called as statics. Whereas in case of the dynamics, the effects are considered in terms of the motion, we are going to call as dynamics. Further, the dynamics has been classified into two types, that is of kinetics as well as the kinematics. So kinetics, it is one of the branch of the dynamics. It deals with the relationship between motion of bodies and the forces which causing the motions. Whereas in case of kinematics, it is also a branch of the dynamics which deals with the motion of the bodies without considering any forces into it. Next, we will look into the general concepts of the mechanics. So if we choose a body which are going to have their identical forces, that we can able to have the combined effects as well as these forces which are causing that effects. And if it is been classified into two types, that is equilibrium as well as the motions. So the equilibrium, the statics as well as the mechanics, that is mechanics of materials, that is rigid bodies as well as the deformed bodies will be considered in terms of the equilibrium, whereas in case of the motions, the dynamics as well as the fluid dynamics will be taken into account. This is the general of mechanics. So some of the basic concepts of mechanics are length, time, mass, forces. These are some of the basic quantities which we will study into the mechanics. Length is nothing but need to locate the position of the point in the space, as well as the time is nothing but it's a measure of success of the events. Mass is the quantity of matter which has been present in the body, as the force is represent the action of one body to the another body. So the example for the length or distance and as well as the geometric properties. Time is basic quantities in terms of the dynamics. Mass, inertia of the body is going to call as mass, and force, which is a vector quantity. So the physical quantity is nothing but any quantity which can be measured is called as physical quantity. The fundamentals of the basic quantities as well as the derived quantities are the two types of the physical quantities. So the mutually independent quantities we are going to call as the fundamental quantities, and the quantities which can be expressed in terms of the fundamental quantities is called as the derived quantities. For example, velocity is nothing but distance by time taken, whereas the linear momentum is nothing but mass into velocity. There we can able to adopt that velocity is distance by time taken, so mass into length by time. So the velocity is a fundamental quantity and mass is the derived quantity. Next, these are some of the basic units of your mechanics. That is mass, we can be able to call as kilogram, length is meter, time in seconds, and force in terms of Newton as a SI units. For example, as per the Newton's law of motions, we are having force is directly proportional to acceleration. So F equal to m into ma. Therefore, m is nothing but mass in terms of kilogram, and a is acceleration, that is m divided by s square. So kilogram meter per second square is a unit for your force. Next, system of mechanics. So the following systems of mechanics are there. So CGS system, FPA system, MK systems, and SI systems. So basically, we are covering about the SI systems, that is units of length, mass, and times in terms of meter, kilogram, as well as seconds respectively. Next, we will cover about the basic laws of mechanics. So the laws of mechanics deals with Newton's first law, Newton's second law, as well as the Newton's third law. So Newton's first law is concentrated forces. We can able to say in terms of the idealization of particles. So the effects of loading, which is assumed to act at the point that is on the center of gravity, is nothing but concentrated force. So the examples for the concentrated force has been given here, that is contact force between the wheel as well as the ground. It is one of the example for your concentrated force. Next, the Newton's 3 laws of motion, as basically I said. So first law, the body which is originally at rest or in motion in straight line with a constant velocity tends to remain in the state provided the particle is not subject to an unbalanced force. This is Newton's first law. So the first law contains the principles of equilibrium of forces. So we can able to see the equilibrium, that is forces are acting on a body in terms of the equilibrium. This is an example for your first law. Next, second law. So second law basically known as mass is directly proportional to acceleration. So F is directly proportional to A. So F equal to M into A. So we can able to see the body which has been moved with respect to the force and as well as the acceleration. So the second law forms the basics for most of the analysis in case of the dynamics. So F is equal to M into A. And next one is the third law. Everyone knows well, third law, every action that is equal and opposite reactions is there. So the mutual forces of action and reactions between two particles are equal, opposite and collinear in nature. So action, if there is any action is there, reaction will also occur. So that is the basic concept of your Newton's third law. So we can able to see here. So first one is inertia, Newton's first law of motion. So the object will remain at rest until a force has been applied. That is Newton's first law. The second law is whenever the force has been applied, the acceleration will also be there. So force is directly proportional to the acceleration. So that is about Newton's second law. And Newton's third law, every action is having equal and opposite reaction. For example, if you are going to bullet or fire over there, we can able to have the action was fire and the bullet has been passed over there. So it is an example for your Newton's third law. So one more law is that Newton's law of gravitational forces. So that we have to consider two masses which are all in different sizes. M1 is of mass 1 and M3 is of second mass. So as per the Newton's gravitational law, we can able to say F equal to G into M1 into M2 divided by R square. It's nothing but the rate of the body is related to computer in statics as well as the dynamics. So this law covers the gravitational attractions between any two particles. So some of the basic equations in the engineering mechanics are parallelogram law, algebraic solutions as well as the trigonometric law. So parallelogram law is nothing but if two equal and opposite forces are acting on the body, the diagonal represents the resultant of the forces. Similarly, the algebraic solutions will combine of your cosine law. So as per the cosine law, the formula will be given as C equal to A square plus B square minus 2AB cos C. And as per the trigonometrical solutions or the sine law, we can able to say the opposite sides of the angles will be mutually perpendicular to each other. So A divided by sin A equal to B divided by sin B equal to C divided by sin C as per the trigonometrical relations or otherwise the laws of cosines. So thanks for your watching. Thank you very much.